Hello everybody, let's look at number 2. We have a rectangle that has one corner in quadrant 1 on the graph of y equals 16 minus x squared, another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis. What we want to do is express the area of the rectangle as a function of x, identify the domain of the function, graph it in Desmos, and use the graph to find the x value where the area is the largest. We'll then identify what that point is called. And again, to do this problem, it's going to be helpful to sketch the curve. So let's look at, go ahead and look at that. We are just in quadrant 1. And so the vertex is at 0, 16, and the x-intercept just in the first quadrant is going to be at 4. So the graph's doing something like this. And so let's go back and look at this problem. A rectangle has one corner in quadrant 1 on the graph of y equals 16 minus x squared. So that means in our rectangle we have a point here, there's another at the origin, another on the positive y-axis, and then this another on the x-axis. So this is our rectangle. And so what we now want to do is find the area of this rectangle in terms of x. We know the area of a rectangle is length times width. So if we know that this is the origin and this is the x-axis, we can just call this distance x. And at x, this will be at a height of 16 minus x squared. So our length is x, going to be 16 minus x squared. We can clean this up, and now we have it as the area as a function of x. We'll have negative 16x cubed plus 16x. All right, so that is the area. Part A. Okay, so for part B, we want to find the domain of this function. So when we look at this function, we already know that the domain of this is going to be all real numbers. It's a polynomial. But in the context of this real world problem, we want to maybe look at the graph and see that for this rectangle, another option that we have to draw this is that we can maybe have the point on the curve be right here. We still have the origin on the positive y-axis, and then here it would be on the positive x-axis. This forms another rectangle. And so what this is alluding to is that the value for x has to be somewhere between 0 and 4, not including 0 and 4. We can write this a couple ways. We can use set builder notation. And so the way we do that is we'll use curly braces. This will be the set of all x such that x is between 0 and 4. And it's not including 0 and 4. We can also use interval notation, and that would be 0 and 4 in parentheses. So these are the domains. Now, what we're going to do is go ahead and graph this function using Desmos, and then we'll find the x value for when this is its largest on this domain. Alright, so here's the curve. I suggest when you're in the Canvas shell, you can play with the window because there's more to this curve than what we're looking at, but we are just focusing on 0 to 4. And so we can go ahead and use Desmos here. If you just use your cursor, the maximum here is going to be at 24.634. So that's the area, 24.634 units squared. That's going to occur when x is equal to 2.309. So when x is equal to 2.309, that's when the area is going to be the largest. And I did allude to the fact that this point is called the maximum. The maximum is the largest because all the other points are going to be, all the other y values are less than or equal to that maximum value. Alright, so that's number 2. I'll see you again in number 3.